All right, so we can use de Moivre's theorem to, instead of raising to a power, kind of do the opposite, do the inverse of that, and find roots. So if we let W equals R times CIS of theta sub 0, or let's call this R e to the I times theta sub 0. So let this guy be a complex number. Okay, let's start there. And as long as this guy doesn't equal 0, we can find the n distinct nth roots, and they would be given by this. So the nth roots of W would be this. So Z sub k is equal to the nth root of R times CIS of theta naught over n plus 2 pi k over n. Or if we're doing this in an exponential form, you would still have the nth root of r, but then it'd be times e to the I 1 over n times theta sub 0 plus 2 pi k. And with all of this, k is going to equal 0, 1, 2, all the way up to k minus 1. And this will be how we find all of the roots for the indicated number. Not the k minus 1, I'm sorry, n minus 1. So that means that if you are looking for the cube roots, your k is going to go 0, 1, and 2. So there's going to be 3 of them, but you're going to start with the subscript of 0. And you're going to plug in 0 for k and go at it that way. So for example, if we want to find the fourth roots of negative 4 minus 4i. Now, you'll notice that the formulas we have above require us to know the r and the theta. So before we jump into anything, we've got to find that. So my r value is going to be the square root of negative 4 squared plus negative 4 squared. So 16 plus 16, which is the square root of 32, and that reduces to 4 square roots of 2. All right. Now, your theta, again, is going to go back to tangent of theta. That's going to be your y value, negative 4 over x, negative 4, and that equals 1. Keep in mind that this complex number being negative for the x, negative for the y is going to put you in quadrant 3. So we're in quadrant 3, does tangent equal 1? Well, that happens at 5 pi over 4. It's got that reference angle of 45 degrees, or pi over 4. So then what we want to do is that we want to use the form that we have above to list all of our roots. Now, once you know what r is, this piece right here is going to be done. The only thing that's going to be different for each of your answers will be what is the angle that's going to be inside for your polar form or your exponential form. So let's actually do that off to the side. So my k is going to go 0, 1, and 2, and 3, right? So we want to look at doing, so that's going to be my theta sub 0. So your theta sub 0 is 5 pi over 4, but then we have to divide that by n. So it means we have to divide this by 4 because we're doing the fourth roots, and that gives me 5 pi over 16. And then what I'm going to be doing is I'm going to be adding, so then you have to add 2 pi k over n to get the other iterations here. So that means plus pi over 2 times k. And k is going to go 0, 1, 2, 3. So with the 0, this is going to be your first one, right? What's your next one going to be? Well, your next ones will be adding pi over 2 to that. So I don't know about you, but sometimes I have a hard time adding fractions, especially if I keep doing it over and over again. So what I like to do is I like to see this as, instead of adding pi over 2, make it out of 16, make it out of 16ths. So this is going to be 8 pi over 16 times k. So we're going to be adding that each time. So your angles will be 5 pi over 16, add 8 to that, so we'd have 13 pi over 16, add 8 to that, 21 pi over 16, add 8 to that again, and 29 pi over 16. And you'll see that all 4 of these angles are going to be within 0 to 2 pi. All right, so let's actually write the answers. Now this is going to be kind of messy because we need to do the 4th root of 4 square roots of 2. Here's the rub, right? If I want to do this, that just looks kind of messy. I'm not a big fan of that. So instead of me doing that, I'm going to look at doing the 4th root of the square root of 32. Because if I rewrite these in terms of powers, the 4th root is 1/4 power. For 32, in the square root, that's going to be the 1/2 power. So really I would have the 1/2 power to the 1/4 power, so power to power, you'd multiply those, and that would give you 32 to the 1/8, which is just saying the 8th root of 32. So either way, whether you want to write the 4th root of 4 square roots of 2, or you want to write the 8th root of 32, it's going to be this. It's going to be fine. So your roots, your first root is going to be the 8th root of 32 times CIS of 5 pi over 16. Your next root, again, the 8th root of 32 times CIS of this next one, 13 pi over 16. Your next root, the 8th root of 32 times CIS of 21 pi over 16. And your final root, still the 8th root of 32, CIS 29 pi over 16. And these are the 4 fourth roots, the 4 complex 4th roots of -4 minus 4i. Now, we could double check this. Not sure it'd be a whole lot of fun, but let's see what we can do here. So doing the 8th root of 32, I'm going to say 32 raised to the 1/8, and then times. So I've got the CIS stuff over here. Let me just simplify that and just do the exponential form. So e raised to the I times 29 pi over 16. If we've done this correctly, we should get -4 minus 4i. All right. We shouldn't, though, because I'm forgetting something. What I need to do is I need to put all this in parentheses and raise this to the 4th, because we were finding the 4th roots, right? So this should now give you -4 minus 4i. And if I were to go in here and change this from 29 to 21, and it still raises to the fourth power with negative 4 minus 4i. Okay, so there we go. Yeah, I just forgot the fourth power when I was trying to check this, which is very important, right? Got to make sure we remember that. All right, so let's look at another one. This is not going to be as fun, and there will definitely need to be some rounding going on, but it's going to be okay. So if I say that W is equal to 7 plus 3i is my complex number, and I want to find the cube roots. Find all the cube roots for this, the 3 cube roots, right? Well, first, we need to find r. So r is going to be the square root of 7 squared plus 3 squared. So 49 plus 9 is the square root of 58. Simplify if you can, but you won't be able to, so we're just going to leave it as it is. Tangent of theta would be 3 over 7. Unfortunately, this is not one of those guys that we know. So we're going to have to throw this into the inverse tangent function and see what we come up with. All right, so inverse tangent of 3 over 7. Check my mode. I'm in radians. All right, cool. So this gives me something that is approximately 0.40. Yeah, let's go up to thousandths or 10 thousandths. 0.4049. Okay. Now we're doing cube roots. So the form that this is going to take is we're going to have to divide this guy by 3. Then we're going to have to add certain amounts to it each time, right? Because the format that we've seen is that you would take your initial theta over your n value, and you would add 2 pi k over n. So since we have 2 pi over n, for us that's going to mean that we're going to add 2 pi over 3 each time, right? But we have to start off with the correct theta, though. So for the first one, it's going to be this guy divided by 3. So let's go ahead and start writing our answers. So let's see, starting with the first root. Now, it's not going to be the square root of 58. It's going to be the square root of 58 inside of a cube root. So if you kind of think about that off to the side, you've got to do the cube root of 58. Nope. You got to do the cube root of the square root of 58. And that's going to give you the 6th root of 58. Just like above, we had the 8th root. Yeah. So when you have a root of a root, if you multiply those indices, 3 times 2 is 6. That's going to be the root that you're going to use. All right, so this is going to give us the 6th root of 58. And let's do times e to the I. Now, my theta, the first one is going to be what we see here, the point 1350. 0.1350. And then to this, we want to add 2 pi over 3. And that's going to get us the next complex cube root. Still with the same value in front, the 6th root of 58. E to the I, what do we have now? 2.2294. And then the last, I'm not doing these right. Because the way they want you to write these guys, be like this is your first root, down to your last one. All right, so let's add another 2 pi over 3. So the 6th root of 58, E, I, 4.3238. 4.3238. Now, I'm rounding here, so I know there's going to be a few issues. But let's try to check one of our answers and see what we come up with. So I want to try to cube one of these that we have here. Let's start with the last one. If I cube 58 raised to the 1/6 power, e to the I, to the I times 4.3238, and I cube this. Does this give me 7 plus 3i, or at least something that's close enough to it? All right, so it's not exactly 7 plus 3i, but you can see that, that's pretty much 7 plus 3i, right? And the reason it's off is because we rounded. Had we been able to get an exact value for inverse tangent of 3/7, things would be a little bit nicer. But it just kind of is what it is. And we can actually go back and check the other ones while we're here. So we have 2.2294. Again, it won't be exact, but it's going to get us pretty close, right? So basically 7, basically 3i, and there we go. We found the 3 complex cube roots to this number. So with all these problems, you got to find the r, find your theta, and you have to go and build what those different angle measures are going to be. And if you were to look at these angles, if you were to look at these numbers on a grid, you would see that they would all be around a circle, and they would all be evenly spaced out. So yeah, if we were to convert these into, degrees, I'm not sure exactly where these are. Let's see. So you'd have something that would be like right here for one, and here for another one, and then probably down here, where these guys are all spread out evenly from one to the next as you go around the circle. They would all have the same r value, which is the 6th root of 58. It's just you would have the 3 different angle measures for that. All right, so there you go. Hopefully that made sense. And of course, if you have any questions, just let me know.